what takes up the vast majority of JavaScript code? What is it that you see the most in JavaScript? You see two things: assignments and function calls. Those are two things that actually make up the vast majority of lines of code in JavaScript. And if you don't believe me, then look around. Look at some JavaScript code and see how much of the code is actually just assignment expressions and function calls. And that's why I want to talk about assignment expressions today, because they're important. Assignment expressions in JavaScript. And what does that mean? What are we talking about? Let's take a look. The idea of an assignment is pretty straightforward. You take some value, you take the result of some expression, and you assign it into something. You assign it to a variable, for example. Usually that, well, takes the form of a equals b, where a here is actually just a placeholder to mean the left-hand side. Sometimes, especially in math, we abbreviate this. We say LHS to mean left-hand side. And on the right, b is whatever is on the right-hand side. That's pretty simple. So in the middle, really, the assignment operator identifies this as an assignment expression. That's the assignment operator. It's an equal sign, of course, not the double equals or triple equals, which exist in JavaScript, but the single equals, which is an assignment operator. That's it. That is the basic structure of an assignment. So we don't have to go deeper than that in terms of the syntax. That's what it is. What can you assign to? I think this is a valuable question to explore. Well, we're assigning to whatever is on the left-hand side. That is clear enough. But what does that? What can be there? What can you put into the left-hand side? What can you assign to? Variables. In fact, a lot of the time, if you are just talking about assignments, you might forget that there are other things that you can assign to, because variables are the big obvious one. This is what we use variables for, right? We put values into variables, we assign them. But that's not the only thing, right? Because you can also assign into arrays. I mean, that's how you put a value into an array. By assigning some array index to a value. Well, so that's arrays. You might say array members, depending on, like, you might say, okay, we're actually not assigning to an array, we're assigning to the member of an array, right? Because you are gonna be saying the member at index 0, or the member at index 1, or the member at index whatever value n. We're assigning to that actual location in the array. We're not assigning to an array overall. I just want to clarify that's what I mean. And what else? Well, objects too. Also, we're assigning to members of objects. I like to use the word property, actually. So we're assigning to object properties. Properties. Yeah, that's it. That's basically it. I mean, this is where we can put values. We can put them into their own standalone variables, and we can also put them into arrays, into objects. That's great. So this is where our assignment operator is used. That's where it's powerful. But I want to jump straight into some examples. Okay, I just want to make it super clear that there are a couple of ways we can do these assignments. So let's look at some assignment expressions. So I just want to clarify that, yeah, these are expressions, although usually when we're using a variable, we are using a constant or a const, a let, or a var keyword. But aside from that, the rest of this is the part of that statement which is really the assignment expression. So this is basic. We're assigning a value here. It goes into this constant age, this value. Okay, good. What's going on here? Well, here we're assuming that names here is an array, and we are just simply assigning a value here, which happens to be a string, into the member at index number 2. Okay, so array. So that's I just want to illustrate. Yeah, this is how you put values into an array. You use an assignment expression. Now, what if we actually have an object like this one here? Well, similar thing, except now we can use this property syntax, right? Which is using the dot operator. That's a property. And finally, as the final example, we again have an object, and this is our alternative syntax, where we're using the square brackets here, but where we also are talking about a property because this is an object. And this is an alternative syntax for accessing properties where the name of the property, the key of the property is actually given as a string value. This means that this string is actually, it's a sub-expression. This could be a string like here, but let me just clarify. I mean, because this is a sub-expression, it could also be anything that is a variable. I mean, I'll just name it something else here. Suppose I have a variable s, then this is allowed because s has some value as an expression that is going to evaluate to, just as here age is a string, so we gave this literal value age, but it could have been a string that was stored inside of a variable. That's just a side note to say that this is a sub-expression basically. Now, let's not forget that this is also true for the array index here. This is a sub-expression, which doesn't have to be a number in a literal sense like this. It can also be a value that's from a variable or for somewhere else. Okay, so let's look at some examples of what happens when an expression is, an assignment expression is evaluated. And the reason why I want to take this little tangent is just to illustrate the difference between assignments that happen by value and assignments that happen by reference. Because ultimately an assignment is copying a value. We're copying a value from one place to another. In this example, right, we have, again, a value, and it's like it's just being copied. So it's like we're actually saying with the equal sign, with this operator, we're saying copy the value. So now what happens when you have already a value defined like a, and you say I have a new constant b, and I'm actually taking the value of a? Well, it helps to illustrate this with a little diagram. I like to use little diagrams for this because a variable could be represented as a box. So our variable a right here, it's like it's a box, and we have a value which is then copied over, just like we illustrated here, just like above, right? Okay, so we've placed this value 42 into the box that is the variable a. Now, what happens though if we have this second expression? Well, we start out with now on the left a box b, and the value on the right is actually not just a value that's literally right there, a literal value, but it's instead this variable a. So then a copying operation happens where we happen to know that we had the value 42 here, and copying it over results in it being placed in this box, right? So far so good. We're let me just write it again. We're seeing a copy operation take place. What about with values that aren't simple, so-called primitive values? What if we go to arrays, objects? What happens if we have a value here? Well, we have an array called values. Well, let me rephrase that actually. We have a variable called value. So let's just draw that in the same way, where values is now a box. It's a variable. And on the right hand side, well, we actually have something a little bit more complex going on. This expression is an array expression. What happens when an array expression gets evaluated Well, it evaluates to an array value. I like to make that distinction as clear as possible. The fact that on the one hand we have an array expression. That's something that you write in the code. Expressions are pieces of code like this one. This is an array expression. And a value is something that exists in memory. So when the expression gets evaluated, we obtain basically, that's what is the result of that evaluation. We obtain an array value. Sorry, it shouldn't be plural. We have just one array value. And now, how do you draw an array value? Well, I like to draw it as a little ladder diagram kind of thing, where we have slots. And an array obviously has indexes, so we can write them here where each of these slots has an index. And just like in this code sample here, this expression really in the sample, we have a few values, right? Let's just put them in here. So now, this thing here that I drew is an array value in memory. That's what was created when this expression was evaluated. Now you notice that that's bigger than this box that we have. So we can't actually fit the array into this box. And that's where references come in. So instead of storing the entire array into the variable, what happens when an assignment happens with an array value, it actually puts a reference instead of the full array. So this reference is like an arrow that then points to this array, which exists right there. Actually, it just exists in memory, just sitting there, maybe not so far away from the actual box, but it's not in the box. Instead, we have a reference that points to it. This is important because what happens if we have another expression where we say we have a variable values2. Okay, this is another variable. And what if the assignment that I'm going to write actually says that values2 is going to be assigned the value of values. In other words, that very same variable that we have above. So what happens now? Well, let's draw it again. Let's draw the same thing. So now, once again, on the left we have one variable, which is called values2, and on the right, well, what's the expression that we have on the right? It's the value that's inside of this variable values. But what's in here? I mean, if the copy operation is like we just saw before, this is what we want to do, right? This is what we want to happen, this copy operation. So what's going to actually happen? Well, what's in this box values? It's a reference. It's a reference where it's one of these arrows that is pointing to this array that we have in memory. So what happens to the copy? Well, it copies what's in the box. That's it. It copies what's in the box. So what are we going to end up with? We're going to end up with a copy of that reference, which itself is an arrow, pretty much. Like a reference is sort of an arrow pointing to something. And it's going to point to that same array. That's what happens when you assign an array, and that's the same thing that's going to happen when you assign an object. So that's a summary of this concept of assignments that happen for so-called primitive values. These assignments happen by copying what's in the box, so copying the whole value over into the new variable. However, with values that aren't so-called primitive values, so that includes arrays, objects, functions, with these values, it's not the value itself. It's not the array or the object or the function that gets copied. Instead, it's just the reference, which means that the object or the array doesn't get copied. It still stays in the same place where it was in memory. Instead, just the reference to it gets copied. And you might say in both cases, the contents of the variable get copied. But in one case, it's a reference, and in the other case, it's the actual value. So Just to reiterate, what are the primitive values that get copied in their entirety? Well, we have numbers, we have strings, we have booleans, and a couple of the, well, the special constants that include null and undefined, for example. These also are just primitive values that get copied over, and they are not copied by reference. Whereas anything that's an object, and that's in the broad sense, because in JavaScript, all these things that aren't primitives are technically objects, but point is that this includes arrays, objects, and functions as well. That's great to keep in mind. Functions aren't copied; they are the references are copied as well.